if I'm to have this, so I'm gonna make it here to say first thing here, let what? Let's start with what? Let u be equal to cos x, right? And then you've got du over dx. Now cos, when you differentiate cos, there it is, cos becomes minus sine. Okay, so you come here, says negative sin x, right? And then you continue again also and say let, you can use another one, let ln what you call, let's say v is equal to ln x, so it will be dv over dx is equal to, now ln, remember when you're differentiating, ln is 1 over x in a way, k over x, so in here I'll have 1 over x. So which means if I'm to apply the formula now, it will be y is equal to, let's come to the formula. This is the formula that I'm going to be using. Okay, dy over dx, let's look at that. Dy over dx is equal to, now the formula says what? Ux, u of x. So I'm coming here, I'm taking, this is my u of x, which is cos x. So it's u of x. See, I'm taking that formula, and then v prime x, this one, it's v prime x, and then what are they saying? Plus u1 of x plus u1 of x, and then what do I have? V of x and dot v of x, and then all over v of x squared, v of x squared. This is the formula there. So let me apply this formula. So it will be equal to u of x, which is there. This is my u of x, is cos x. Cos x in bracket. It's very important that you put this thing in bracket. U of x times v derivative of. Hello, most developed student. My name is Confident, and welcome to the continuation of this revision session. And we've been looking at this paper, and it's the November 2022 question paper, the latest as I'm doing this video, and we've just looked at question 1. Just to pause, maybe you want to take a look at it. So this was the question 1 out of 20 marks. This became the question 2. I think you can try to fit it there. And also we looked at question number 3, and then there was some work on question number 3. Now we are looking at question number 4, and this is calculus. So as I say, I hope it will fit in here. So let's look at question 4. It says determine the following limit. Then it's how much? 3 marks. Lim, let's just simplify this thing. It says lim x, not h. So x approaches 2. So what do you have? We have got x cubed minus 8 over x minus 2. So guys, it's already obvious that you cannot substitute 2 here, because the moment you substitute 2, this thing will become undefined. You can see that when I put 2 at the bottom, it will become what? This will become 0. So at the end of the day, it will become undefined. So you cannot put 2 at the bottom there. What you need to do is first of all, you need to factorize the top. This is a cube. I hope you are able to see that this is a what? A cube. And if you have to factorize a cube, remember the general form says a cubed. Let's start with the plus, b cubed. You know how to factorize a cube. It's very important that you know. So you pretend you don't have these 3. So what do you say? It's a plus b, right? So you write your a plus b here, and then also on the other side is the squared and the squared, and you multiply a times b is ab. Now if it's a plus, it's minus and plus. Always a plus in the end, always a plus. The signs interchange. If it's a plus here, so this sign is that sign, but this sign opposes that sign. All right, but here always positive, always positive. Now let's do the negative one. If I give you a cubed, it's a cube, minus b cubed, all right, it's the same thing. It's a, now you see a minus b, right? And then when I come here, it will be a squared. Now oppose the sign, plus multiply a times b, which is ab, and then always positive b squared. You see that? Okay, like that. So there it is. What do you have? Same sign, negative, positive. So that's what we're going to do here. I think you can see already. That's what we're going to do here, whereby this 8 is simple what? It's simple 2 cubed. 8 is 2 cubed. Are you seeing that? So you open a bracket on top where you will have x minus 2, and then multiply x times 2. So it will be what? Squared first, sorry, x squared. And then now it's negative. You what? You interchange from negative. The sign here will be what? Positive. Are you getting that? So it's x minus 2 plus multiply 2 times x, which is 2x, and then again always positive what? 2 squared. Now are you seeing that? And then this is all over x minus 2. Are you seeing that? At this stage you are able to cancel out what you don't want, which is that and that. Are you seeing? And then from here you are able then to finalize what do you call this? You are able to quickly differentiate, find the limb. We're not thing. This is equal to, remember it's a limb. Let me not lose sight of what we are doing. So this I was supposed to continue and put that sign here as what? Limb x approaches 2. So you can approach 2 now. It will be 2 squared plus 2 plus 2 squared, which is equal to what? 4 plus 4 plus 4, which is equal to 16. This thing will become 16. So that was the answer in that part. All right, making sense? I think so. All right, next question here. It says differentiate with respect to x, y is equal to log 5x with the aid of the function of a function, chain rule, function of a function. Show all intermediate steps in substitution. 4 marks. Okay, function of a function, they want you to use the chain rule. And then what we have, y is equal to log 5x. Let's take this thing here. So the chain rule, now if I bring the formulas to this thing, where are my formulas? Okay, these are the formulas. So if I'm to bring in here to say which one is the chain rule, now remember we are here now on dy over dx, and then there is the chain rule to say dy over dx is dy over du times, not this, times du over dx. So we are having this as the chain rule that they need. So what I need then to come here and say here I can use this one and say let what? U be equal to 5x, such that du over dx is equal to 5. So what do I have? I've got my y is equal to log u. Are you getting that? Now I just got a little bit of, when I'm differentiating log. If I'm differentiating log, okay, come here to the formulas. Let's start with the formulas. You see, they don't give logs here. The main differentiation, if you've got y and you're differentiating, the easier one is the most closest here I have is k ln x. You see this one, which is also here. No, they don't have here. So if I'm differentiating, the simple thing is ln x is 1 over x. That's my dy over dx. So can I convert this into ln? The answer is, I feel like I want to convert this into ln first. So what will I do? Let me open a window here just to show you, to say I want to convert log u, not to find dy over du is fine. You can differentiate straight away. But look, let me convert to ln so that I can use the formula. So what do I have? Look, if I say log u is equal to, I'm converting it to log, remember this is in base 10, so I'm going to convert it to base e. So it will be log base e of u over log base e of what? Of 10, right? And you know what is log base e? It's ln. So this is ln u over ln 10. Are you with me? So here I can continue now and say y is equal to ln u over ln 10. Now, you know, this is more like my k now. This is more like my k. So it's same as saying y is equal to 1 over ln 10 is a number, and I'm differentiating ln u, such that if I say, so this is more like my k, this one is my big K. Alright, so you can use the formula here. Remember, the formula was more like, if you're looking at k ln x is k over x. You see that? So that's what I'm going to do here. What it means, remember this is that part to say my y, dy now, over dx is equal to 1 over ln 10 and then 1 over u. See, which is 1 over x. Are you with me? Then I can now apply the what do they use? They say use the product here, function of a function, actually chain rule. The chain rule, I can apply the chain rule. What does it say? It says dy over dx is equal to dy over du times du over dx. Are you with me? Which is equal to dy over du, we just have it here, which is 1 over ln 10, 1 over u, times du over dx, and du over dx is 5. Did I miss out anything? Yes, it's 5 there. That is fine. This is 5. Alright, but now, which is equal to, I need to say 1 over ln 10, 1 over, now what is u? We did mention that u was equal to 5x. Remember, u is 5x. So I can come here and say, where there is u, I put my 5x and then times 5. Then this is equal to, you can then cancel that part. Are you with me? What does it become? It becomes 1 over ln 10, actually 1 over ln 10. Okay, how can I write this one? I want to say 1 over x ln 10. It's fine like that. Right, but or write it like this to say 1 over ln 10. I think it's fine to leave it like that, 1 over x, because here the x becomes a power there. Becomes like that if I take it back, but anyway, that's fine. That is the part. And if you want, yeah, that is the part here. This is the part. I'm comfortable with this. And then should you have wanted to differentiate this straight away, that what are we having here? Y is equal to log u. So what does it become? Dy over dx is equal to, now what we have got in here log, I think it will become log e here. Is it log e over u? Something. Am I right? I think I can test this first. I think I can which is equal to dy over du, not dx, du. Right, so it's log what? E, see that, over u. So now if I can now use the quotient, the chain rule here, dy over dx, so what I will have is dy, I'm just testing this, is equal to du dy over du times du over dx, which is equal to dy over du. We just did it as log e over u times du over dx is 5, remember. So we come here, u is 5x, which is log e over 5x times 5. I think it's coming out right. Cancel that, cancel that. The answer is log e over x. Now the question is, are these things the same? Log e. Now let's look at the numbers. Remember what is log e, which is equal to log e is more like you're writing like this, log in base 10, or we just say log alpha e, like that, equal to, this is 0.4343, 0.434. So it's more like you've got 0.43. I just want to check something over x. Right, let's check the side here. What will be this one? Is 1, remember 1 over ln 10. I mean ln 10 is at the bottom, right? We have got ln 10 at the bottom. So if I say 1 over ln 10, what does it give me? And then will it give me in the same, if I say 1 over ln 10, what does it give me? 0.4343. Yes, there, 0.43. So it's the same thing, it will work out the same. Okay, all right. So which means in here, don't forget, so if I'm to differentiate log x, that is my y is called to log x. Yeah, I think this is it. Instead of converting to log to ln, so it's dy over dx is equal to log e over x. All right, you comfortable? That's that. So dy over dx is equal to log e, so you pull out an e because you're dealing with ln over x. All right, so let's look at the next one here. So that was 4 marks. Differentiate with respect to x, y is equal to this cos x over ln x with the aid of a quotient rule. Now when they're talking about a quotient rule, okay, I think I seems like to be having raised 2. Okay, so that is, I don't know why it's giving me. Okay, that is fine. Let's look at this one, quotient rule. Let me look at the quotient rule. We are looking at this one. dy over dx is ux times dv over du. This is dv, the derivative of v, times derivative of u of v of x. I'll try to apply that formula. That's what we're using. So let's look at this. If I'm to have here y is equal to cos x, right? Y is equal to cos x over what? Ln x. It's just 3 marks. I wanted it to have more marks than the chain rule, but I don't know why. They just gave it 3 marks. Look at this. If I'm to have this, so I'm gonna work it here to say, first thing here, let what? Let's start with what? Let u be equal to cos x, right? And then you've got du over dx. Now cos, when you differentiate cos, there it is, cos becomes minus sign. Okay, so you come here and says negative sin x, right? And then you continue again also and say let, we can use another one, let ln what you call, let's say v is equal to ln x, so it will be dv over dx is equal to, now ln, remember when you're differentiating, ln is 1 over x in a way, k over x. So in here I'll have 1 over x. So which means if I'm to apply the formula now, it will be y is equal to, let's come to the formula. This is the formula that I'm going to be using. Okay, dy over dx. Let's look at that. Dy over dx is equal to, now the formula says what? Ux, u of x. So I'm coming here, I'm taking, this is my u of x, which is cos x. So it's u of x. See, I'm taking that formula, and then v prime x. This one, it's v prime x. And then what are they saying? Plus u1 of x plus u1 of x. And then what do I have? V of x and dot v of x, and then all over v of x squared, v of x squared. This is the formula there. So let me apply this formula. So it will be equal to u of x, which is there. This is my u of x, is cos x. Cos x in bracket. It's very important that you put this thing in bracket. U of x times v, derivative of v here, the derivative of v, which is 1 over x. You see this? So v, this is v. In a way, this is my v prime x. See? So it is what? Times 1 over x. Then plus u prime x. This one is my u prime x. Are you with me? So u prime x is minus sin x, negative sin x, okay, and then times v of x, which is ln x, and then all over what? V of x squared, which is ln x what? Squared. Alright, so basically, did I write it right? Yeah, cos u of x, let me check again the formula. The formula said u of x derivative of v, u of x derivative of v. Yeah, that is that. So my u was cos x, derivative is what? Of v is that one, 1 over x, and then times that, the derivative of u, which was negative sin x, v of x ln x. And then you can simplify this if you can further, but I think that's it. So it's simple, 1 over x cos x, yeah, minus sin x dot ln x over that. Yeah, that's done. Nothing can be done, I think, here. Ln x squared. I think the top answer can be enough here. Maybe that's why it's just 3 marks. Now differentiate with respect. Let's look at the next one. Differentiate with respect to x. Then they give me this. Right. Let me try to write it down also here. What are they saying? They are saying, if I try to write it down, they are saying y is equal to negative half cot x, negative half cot x, and then what? Minus square root of 2 cos x, minus square root of 2 cos x, and then what? Plus 1 over 3 log 7x, alright, plus 10 to theta. Okay, so this one, alright, if you can just look at this question like this, the way I'm thinking of it, there are some things that we did that are similar. For example, if I'm to differentiate, okay, cot is not a problem. This one, alright, if I'm to find dy over dx, let's look at the first one. This, just let's flake out a few things, guys. This is simple 0, and this guy here, we differentiated log. Where is that one? I hope I didn't lose it. We did differentiate the logs. Thank you. I got it. Log 5x. Remember, we did differentiate log 5x. So log 5x gave me this one, 1 over 10 ln 1 over ln 10 bracket 1 over x, because I don't see the 7, so the 7 disappears in a way. So in other ways, it was this log e of x, remember, so I can choose to write it like this, log e of x. So if I can come here to say this is log e over x, or write the other one, which is 1 over ln 10 1 over x, can be this one or that one. See, now the other one here, look at it, I'm differentiating what? Cot. What is cot? Cot becomes minus cos x squared. So here you can see they say to become minus cos x squared x. And what about cos? Cos become what? Is it sine? Cos become actually cos x is negative sine x. This one is negative sin x. So if I now apply the rules and say dy over dx is equal to minus 1 over 2, now it's negative cos x squared x. See, I'm applying now dy over dx minus square root of 2 bracket negative sine x plus 1 over 3 bracket, let's use the top one, is also fine, log e over x. What next? What next? Plus 0. No, that was that. Then we can go on and say this is equal to negative here becomes a positive, so it's 1 over 2 cos x squared x, again negative there, plus root 2 sin x, I'm adding, so I cannot just simplify this further, and then plus what? Log e over 3x. And as I said here, you have an option that if it was me, I would have allowed to say also plus 1 over 3 x ln 10. To me, this is still the same. You know, that was still gonna work, because the 3 and the x will multiply into that. Alright, so that is that, guys. Give me your thoughts. What do you say? Last one, 4.5. Calculate the coordinates of the turning points of y is equal to this. Distinguish between the minimum and maximum turning points with the aid of the second derivative. 6 marks. Alright, so they gave this one 6 marks. Calculate the coordinates of the turning points. So what is this one they are saying? This one is y is equal to x cubed minus 9x. Alright, let's do it this side. So there it is. Obviously, when they say they want the turning points, remember what you must always know is that at turning points, at TP, what? dy over dx is equal to 0. So let's find dy over dx there. So we've got dy over dx is equal to, you drop there 3x, 3 minus 1, minus 9 of 1, which is 3x squared minus 9. And then we did mention to say at turning point there, so it will be 3x squared. If I'm to apply it this side now, 3x squared, it will be equal to 9. Divide by 3 on both sides. What do I have? I've got x squared is equal to 3. Now look, I have to square root both sides, but don't forget it's plus or minus. Do not forget that. So x is equal to plus or minus square root of 3. I don't think you can simplify this, leave it like that. But now they say the coordinates of the turning point, meaning you need to go to the original to find the y value, to say when x is equal to positive square root of 3, so y is equal to square root of 3 cubed minus 9 square root of 3. Then we're going to get our answer. Let's do the other one. When x here is equal to negative square root of 3, so you've got y is equal to negative square root of 3 cubed, remember, minus 9 negative square root of 3. Let's also see the two answers. So now let's start with the first one. You say bracket square root of 3 you close cubed, right, minus 9 square root of 3, and then the answer is what? Negative 6 root 3 is negative 6 root 3 times. Now let's put the negative there. The first one was negative 6 root 3, negative 6 root 3, positive 6 root 3. So this one is 6 root 3. If it's negative, it becomes positive. Then this one is negative 6 root 3. This one. Now you can put these in coordinates form. How do you put them in coordinates form? Here you come and say, let me use something different. Here in coordinate form, I've got x is positive 3, y is negative 6 root 3. And then the other turning point, x is negative root 3, y is positive 6 root 3. Then they say here, these are the turning points that I have. These are my TPs. From here, they are saying I must identify which of these is the maximum and the minimum turning point, the local minima and maximum. Distinguish between that using the second derivative. You see that? So now, how do I apply the second derivative? Remember, I come back here. This is my dy over dx. Let me, it's 3x squared minus 9. So I've got what? My dy over dx is equal to 3x squared minus 9. So now my d squared y over dx squared is equal to what? 3, drop there, 3 times 2, it's 6x. Alright, so now what do you know about the minima and maxima? What you know, remember this, the second derivative d squared y over dx squared, if it's less than 0, meaning if it is negative, we call that the maximum. And then the opposite is true, the d squared y over dx squared, if it is greater than 0, meaning if it's positive, we call that point the minimum. That's all that we're going to take. So we're going to take this value and we take the coordinates, the x values. So the first one, remember, when you say when x is equal to square root of 3, so d squared y over dx squared is equal to 6 bracket square root of 3, and then this is equal to what? Positive. And you said when it's positive means what? See, greater than 0 means it's a minimum. So when x is positive, this is a minimum point, this one. Minimum. Because when you put the positive one, what about if you put the negative? You come here, again you put the negative to say d squared y over dx squared is equal to 6. You do it because they said show it up. And this is equal to negative. Or you can say this is less than 0. If it's less than 0, it's a maximum point. You see, there it is, less than 0. So you come here and say maximum. That's what they wanted, right? But you still need to show this part to say this is less than 0. And then what do you get? This becomes 6 marks. Not bad. And yeah, that is it, guys. So this question now will end up with this one. Question 5. Let me make it small for you. Just take a look. This is your question 5. Does it fit in? Yeah, it can fit in there. So this, join me in the next lesson. Again, if you guys are benefiting, don't forget to subscribe. Don't forget to share. Sharing is caring. And give me some feedback. Feedback is always what motivates me. If there are some errors, give me some feedback. If you feel like there's some better method, you never know, give me some feedback. Cheers.